Hi everyone! In this video, I'm going to give some tips to those who are starting to learn programming. Formally, these are key concepts and steps in programming. Well, some beginners think that programming feels different than other skills. Yes, I do agree. Well, because we go to school because we want to be smarter each day. And here in programming, we are trying to be as stupid as a computer. So really, because we try to give instructions that the computer can execute or can do, and the computer is not intelligent. The computer does not have a mind of its own. It cannot decide by itself. That's why we have to think of ways on how the computer will do a task and to incorporate some decisions to it that the computer will actually just do or implement. So that's how we should do programming. And actually, it's trying to simplify things. Um, Programming is really thinking about simple simple steps or simple instructions, because that's how the computer will only understand or execute instructions on just based on simple simple operations. And well, some many beginners think that the language is scary because of the codes. It's true, yes, the codes may be intimidating, but then that will only be in the beginning, just a few days. Um, and some think that the environments are scary because of the IDE. There are IDEs that seem complicated or complex, especially upon installation. So as a beginner, we don't have to think about the nitty-gritty of complex IDEs. We can start with simple ones, maybe using a notepad or even IDLE. People can be scary, yes. Some people may be scary. Um, as a freshman, you will meet people, for example, in their sophomore, junior, and they would tell you or give you advice that, are you sure you want to stay in the program? You want computer science? Maybe you can think about it more and start thinking of shifting out now because you need some life. All right. So yeah, some people will tend to give you that kind of advice. And then if you encounter some problems with your program and you ask us for help from an expert or a senior, and some will tell you, oh, that's easy. Maybe some will tell you that's only because of type coercion. But then as a beginner, you would think, coercion, what's type coercion? Okay, so yeah, there could be a lot of scary things in programming, but then those are very um, simple things that we can easily overcome. Okay, so and I'm here to guide you and help you learn programming, um, hopefully in an enjoyable way. So that's actually our goal, for you to learn programming, and you do it not just by reading and not just by listening to my lectures, but um, you do it through practice. You learn programming by doing. That's the only way to learn programming. You have to do it. You have to do all the exercises that we give, all the problem sets, and you have to do it by yourself, because it's a skill that you have to develop. And it's not something that I can feed you or somebody else can feed you. Yes, true. You may get answers or solutions from other people, from colleagues or from classmates, and maybe from internet, but you won't be able to develop the skills. That's why I highly discourage you um, to get answers or solutions from other people or other sources. The solution should really come from your mind, and that's the only way to develop the programming skill, that programming skill in you, because I believe you have it. We just have to bring it out, to develop it, and to practice it. That's why I put here practice, practice, practice. Programming really needs a lot of practice. Okay, so it will require a lot of time from you, and it's okay, because at the end of the day, at the end of the semester, you will learn, and you will already know how to program. And programming is not about languages. Uh, we often think that the language is the factor and why we do not learn, or why programming is difficult. But then it's not really about the languages. Um, the first language you will learn is hard. You will find it hard. And the second language, you would say that, oops, it's harder to learn that language. And then the third language you will learn, you would say that, oops, I'm starting to see similarities with these programming languages, because you will start to realize that all of them have variables, operators, have conditional statements, have if else, and while loops. So somehow they have the same structure, and they follow the same logic. And true, that's true. They follow the same logic, they have the same foundation somehow. And that's what we are going to learn here in Introduction to Programming Languages. And I would say there's no one best language. True, we have to choose a first language that we want to learn. In this case, it's Python, but I cannot say that it's the best language. Um, of course, some languages have their strengths and weaknesses, and we just have to choose which language fits our needs. But then, if you'd ask me, is there a best language? No, I would say there's none. In programming, there is no memorization, not even syntax. So is that a hooray or a boo? So yes, it's true. You don't have to memorize the syntax, because there's Python documentation. There's, well, hey Google. If you need the syntax for print, you can just, hey Google, what's the syntax for print in Python? And you will get it easily. So it's not really about syntax, not memorization. As I said, it's about developing that skill in you, that programming skill, that problem solving skill. Programming languages are simpler than human languages. Um, Many beginners think that the language is a hurdle, or the syntax. Um, I cannot agree to that really, because come to think of it, the English and the Japanese language, they have huge vocabulary, and it's even harder to learn a new um, human language like Japanese than to learn, let's say, Python. Um, the syntax, in terms of syntax, the syntax of programming language is actually much simpler. Well, because it's straightforward, and the human language is much complicated. It's more complicated compared to the programming language. Um, it's more complex. There are ambiguities in human languages. Um, so studying the language is, I think, easier compared to human language. Programming is really about giving instructions to the computer. As I said, the computer has a very simple brain. Um, it can only do simple arithmetic operations. Um, it doesn't have its own intelligence. It cannot decide really by itself. That's why the difficult part really is on how to design our instructions in a way that the computer will understand it, will be able to execute it, and and the computer will be able to do it, um, following the specifications we want to achieve, or the task we want to obtain in the end. So that is programming. That's why the things that we really have to remember or to keep in mind, these key concepts, is very these are very important. We have to remember that programming is really problem solving. um, it's really thinking about the solution to a problem, how to solve the problem, and then what are the steps that we have to design, what are the instructions we have to give for the computer to do it, to do a task. So later on, you'll have bigger problems, maybe real life problems, and then you'd have to solve those using a program. You have to create a program that that does a certain task, and you have to think about what you have to think about really is how to solve, to give instructions to the computer. That is programming. It's not about the codes, as I said. um, the codes are just translations from the instructions to a code, or to lines of text that follow the syntax of a certain programming language. The secret is algorithms and data. So these are the important things: algorithms and the data that we are manipulating. Um, so before you start solving a problem, or before you start coding, you have to think about the algorithm, or the step-by-step solution, or the instructions that we'd have to give to the simple computer. So here are some common mistakes of beginners. Beginners often jump straight to coding. So most students, when they get the problem set, their fingers dive onto the keyboard. I always tell them, as a beginner, you have to start with a pen and a paper. You scribble down things. You write down what should be the input to this problem, and what should be the expected output. So that's how you should do it. And by looking at the paper, the piece of paper, you start to see patterns. It's also about seeing patterns. You see patterns. Oh, there's this pattern. I guess this is how I should solve this problem. So it's not diving onto the keyboard first. So it's really holding a pen and writing down something on a paper. Thinking they don't understand what code to write. Well, maybe because they don't have a solution to write down. That's a problem. You cannot write a code if you do not have a solution in the first place. They start to feel lost in coding. They say, "Oh, I cannot think about the syntax. I don't know how to code it, but it's in my mind." Well, if you feel lost in coding, you do not know what to type, probably you shouldn't be coding yet. Probably your algorithm has not been designed properly. So the important thing is to write the algorithm well, and then the code comes if you have a very well written and nice algorithm. Therefore, the English comes before the Python. So, or the algorithm comes before coding. It's English first, and then you just convert it to Python or any programming language. So these are the important steps in programming. Problem definition and analysis. You have to know what a problem is. You have to understand the problem. And next, write the algorithm. Uh, Design a solution, write a recipe in English. Okay? So write the algorithm. Again, let's go back. What is a recipe? Or what is an algorithm? It contains simple steps. Take note of that, simple steps. Flow of control. And then it contains a point where the program will stop. Just these three. So your algorithm or your solution should have these three. And then if you have a good algorithm already, now you convert your algorithm to code. Okay? After coding, you test using some test cases. You provide values or test cases. If the expected input, let's say, is an integer, you have to try negative integer input, zero input, and then positive integer input. Okay? That's how you create test cases. And then if there are errors, you fix it. You debug it. Okay? When you debug it, that's the time you repeat. So repeat. Which part do you have to repeat? Do you have to repeat the coding part? Do you have to repeat the algorithm part? Or do you have to repeat from the problem definition part? Okay? So these are the very important steps in programming. And then I want to highlight that the most important of this are the first two: problem definition and analysis and the algorithm design. Writing the recipe in English. All right? So do not forget this. Okay? Do not forget this. This will help you a lot. Okay? So, we can write algorithm using English language in a step-by-step sequential manner. Also, there is a flowchart, which is a graphical representation of an algorithm. Flowchart is just very similar with workflow. This is just a typical workflow, and then you use a standard set of symbols to show the sequence of steps and how to show the flow of control. So for this class, we're going to use these symbols. This one for terminal, it indicates the beginning or end of the algorithm, and this for I/O, and then input, output to the computer, to the program. And then this rectangular shape is process, and then decision or condition here. So here, this contains a test. It's a question. For example, is x equal to 10, and so on. And then these arrows are flow lines. This denotes the direction of the control flow or the logic flow. And then this circle is a connector. If you have a big, let's say, big flow chart, and you have to put it in, let's say, 2 slides or 2 pages, you use this connector to connect separate or 2 flow charts. So here's an example. Again, as I said, since the first two steps are the most important ones. We start with a simple example like this one. The problem is write an algorithm that converts a given temperature reading from Celsius to Fahrenheit. So here is the solution in English, or here is the algorithm, or here is the recipe. Okay. Step 1, create a real number variable for Celsius and name it C. Step 2, create a real number variable for Fahrenheit and name it F. Step 3, ask the user enter temperature in Celsius and put the answer in variable C. Compute 9 over 5 times C plus 32, which is the formula for conversion, and put the answer in F. Step 5, which is the last step, tell user the answer is F. Okay? So this is the algorithm. We now have a solution. We can use any language to code this algorithm, this solution. Now, since we're going to use Python, okay. So the flowchart for that algorithm is this one. So so you have here start, create real number variable C, create real number variable F, and then an IO, ask the user enter temperature in Celsius and put the answer in variable C here. And then here we have process. You assign this, the value of this expression to F, and you print out answer is F, and then the solution ends, or the program ends. Okay? This is a solution to the problem. Let's take a look at the second example. Write an algorithm that determines whether a given student's final grade is pass or fail if the passing grade is greater than or equal to 60. So here is a solution in English, the algorithm in English. Create a floating point variable for final grade and name it G. Number 2, step 2, ask the user enter final grade and put the answer in variable G. Step 3, if G is greater than or equal to 60, you do tell user pass. Otherwise, if the answer to this one is false, tell the user fail. Okay? This, we can convert this into a flowchart like this one. Okay? You have a start here, create real number variable G, and then ask the user to enter final grade. And this one is a decision. Is G greater than or equal to 60? If the answer is true, you print pass, and if false, you print fail, and then you end. Okay? So this is algorithm. This is the first step, or the first output that you have to make. You have to create this one before you can even start writing the code. Okay? If you have this, later on in the next video, I'm going to show you that if you have this, it's very easy to convert it to a code in any language. All right? I hope you got a lot of tips from today's session. And again, if you have any questions, feel free to email me or type a message in our group discussion board. Yeah, that's all for today, and have a great day.